A polytropic process is a quasi-equilibrium process that is described by the simple equation PV to the n is equal to a constant. We can equivalently write P capital V to the n equal to a constant as P times specific volume to the n is equal to a constant. So a polytropic process operating between any two states will follow this relation, where we've got P1 times V1 to the n is equal to P2 times V2 to the n. Or if we rearrange that, it might be a little bit more useful as this equation here. Now, when this exponent n has the value of 0, the polytropic process is isobaric. So this V to the n becomes 1, and we have one where we have the pressure is constant, or isobaric. If n is equal to positive or negative infinity, then the process is said to be isometric, or one of constant volume. Now, if we look at the boundary work of a polytropic process, recall that boundary work is equal to the integral of P dV. Well, for a polytropic process, we plug in P into the integral, and with a little bit of work, we can write that as P2 V2 minus P1 V1 over 1 minus n, and that is where n is not equal to 1. Okay? Now, if n is equal to 1, then my boundary work for a polytropic process is going to be equal to P1 V1 times the natural log of V2 over V1. That's for n equals 1. Now, an ideal gas executing a polytropic process we can write T2 over T1, whereas before we would write maybe P1V1 over P2V2. We're now going to say, knowing what we know about our polytropic process, P2 over P1 to the 1 minus n, or excuse me, n minus 1 over n power, and that is going to also be equal to, and I'll try to make sure it stays on screen here, that is going to be equal to V1 over V2 to the n minus 1. All right, so for an ideal gas executing a polytropic process, the boundary work from 1 to 2 is going to be equal to mR T2 minus T1 over 1 minus n, and that is, of course, for n not equal to 1. And for n equal to 1, my boundary work is going to be equal to mRT times the natural log of V2 over V1. And that is for n equal to 1. All right, so that should do it for polytropic process relations.